Problem 4a. fx is ln 5 minus x. Okay, so use integration or differentiation. So ln at 5 minus x, it's very easy to differentiate it, right? So ln 5 minus x, if you calculate its derivative, it is -1 over 5 minus x. Okay, so ln 5 minus x, it's the integration of this part. So ln 5 minus x, it's the integration of -1 5 minus x dx. Okay, then this part is very similar to a over 1 minus r, right? So you want this to be 5. So it's -1 over 5, 1 minus 1 over 5x dx. Okay, then this part, it's exactly the power series, right? It's a power series. It's series from 0 to n, a times r to the power of n. Right. Okay, then you can move this to the outside. It's -1 over 5. Okay, the summation. Then you just have to integrate this part, the integration of x over 5 to the power of n dx. Okay, so this part, it's x to the power of n plus 1 over 5 over n plus 1 times 5 to the power of n, right, plus c. Okay, so this will be c minus 1 over 5, right, summation n from 0 to infinity, x to the power of n plus 1 over n plus 1 times 5 to the power of n. Now what is this c? Okay, you know, ln 5 minus x is this part, right? So you can just sub in ln when x is 0. It's ln 5 minus 0 equals c minus, okay, when x is 0, this power series is 0, right? Equals c minus 0. So c is ln 5. Okay, that's why here it's ln 5 minus this. Okay. Okay, don't forget about, all right, from here to here, right? This is this if the absolute value of r is smaller than 1, right? So here, from here to here, your absolute value of r, so your absolute value of r, it should be smaller than 1, which means your r absolute value, it should be smaller than 5, which means your center is 0, your radius is 5, and right, so this is your answer. Okay, problem 2. All right, x plus x over 1 plus x squared. So if we ignore this x, right, 1 plus x squared, 1 over 1 plus x squared, this is a derivative of -1 over 1 plus x. It's this function's derivative. Okay, so this is x times this function's derivative. And this function is exactly a geometric series, right? A over 1 minus r. it's a summation a times r to the power of n, right? N from 0 to infinity if absolute value of r is smaller than 1. Okay, so it's x times, now here it's negative 1 over 1 minus negative x, right? It's derivative. So this part a is negative 1, so it's x times summation n from 0 to infinity. A is negative 1. Right, what is your r? R is negative square root of x, right, to the power of n, derivative. If, right, if negative x absolute value is smaller than 1, so it's x times, here in total I have n plus 1 negative 1, right, and I have x to the power of n, derivative. Okay, I want this part's derivative, so this part's derivative, it's just n times x to the power of n minus 1, right? Then you multiply this x here, it will be summation negative 1 to the power of n plus 1 times n times x to the power of n, right? If absolute value of x is smaller than 1. So here the center is 0, the radius of convergence is 1. Okay.